Hi there, my name is Ravi Nandiga. I welcome you to my new YouTube series on Oracle Performance Tuning Practicals. Just to give a little background, I've been working on Oracle and various Oracle performance related issues, whether you call it as infrastructure service or SQL related, from past 7-8 years minimum, and pretty much rate at a very good level in tuning the issues. I would be using this YouTube series to share some of my experience. And of course, whatever the exercises or examples I use, the link will be shared in the comment section. So please feel free to comment and suggest if you think I am not correct somewhere. Let's get going. In this first video, I would be talking about a very important concept called data type mismatch, not causing index scans. If we look at all of our production environments, all are pretty much client server architectures. So one example is I can place Informatica under the client region, and as a server, database server, I can keep Oracle here. Right. One of the common mistakes I've seen an ETL developer do, a novice ETL developer do, is use a different data types for a character column. For example, here I have a table called customer, and let's say customer has a column called customer name, and it might have defined as varchar of 30 in database side. Whenever they import or they create some kind of associated table associated mappings in Informatica, the default value for string is nvarchar. It's not a varchar, it's an nvarchar, national varchar, right? So whenever they send a query that involves customer name, developer is thinking that, okay, I already have an index on this table on a customer name, it would pick up the customer name index and gives me the result faster. But in reality, what happens? The nvarchar has to be converted into varchar. In this conversion process, it loses the capability to use an existing index. Instead of an index scan, what it does, it goes through a full table scan. Let me show you that doc reference that Informatica itself placed. I would be sharing this document in the sections, in a comment section. So no need to take any notes, just listen. Performance of queries affected when using nvarchar instead of varchar data type. Right, you can go through this in your free time. But what I would be showing here is a practical example on Oracle database, right? Where on a database side, one column is defined as an integer or a number column. But on the other side, from an application side, a simple PLSQL can be an application side. They use a different data type. Okay. I already tested that a couple of times. I would be just running through this script and explaining you as and when something is important. So let me log into the Oracle environment. I have it in my laptop. So if you see, I have here 19C, Oracle 19C is something I have installed on Red Hat 7.5. It's a standalone server. It's not a rack. It's just a standalone server. That is suffice to explain you this example. Now, before I walk you through these steps, what I'm trying to show here is I'm going to create a table and I'm going to insert some data into it, some 10,000 records or so. And when I run some select statement, when I run this update statement on this employee table by giving employee ID on which I already have a primary key index, it is using index scan, right? This is what I expected. When you have an indexed column and when you query on the indexed column, it's expected to give you an index scan. However, later what I show is I would run a simple PL/SQL where I'm trying to run a similar update statement on the same table, right? Using the same indexed column, but here in my program by mistake I have defined this indexed column as binary float. Okay, now I will show you that explain plan here. My objective is to show here in this case it does not use index. Why? The problem is data type mismatch. The common mistake that we see in our production systems. Very simple mistake, but it has a huge impact on the performance. All right, let's get going. Now I already connected to the database here. If I say select star from, all right, I already have the table. Let me drop the table. Now I am creating the table here, which has very simple columns. Like I said earlier, I'll be sharing these scripts. Right? The scripts will be available in the notes section or a comment section. I'll be inserting 10,000 records where the employee ID will be a unique number. So this is the easiest way to collect statistics. I'm collecting 100% stats. All right. Now let me run this code. What this code does is it will generate explain plan. It does not really execute the query. It just shows the path, right? If we really run this update statement, what it is showing is it would go through an index scan. Why it has sys underscore? Because the primary key index is generated by system. It has its own naming. All right, so far so good. No, nothing out of uh, expectation. Nothing is unexpected here. You know, you have an index and it's expected to pick up a primary index. Yes. Now what I do is, right, let me open a different session. Oh, as a matter of fact, you can run it in the same session, but just to show some difference, right? Assume this as an application session. Okay, what I would be running as an application user is a simple PL/SQL script, right? Very simple. I am declaring new variable, local variable, but this time see, I'm declaring it as a binary underscore float. So I'm assigning 9999 because I have inserted 10,000 records already. And the procedure is successful. That means the update statement did finish. Now, whenever something executed in Oracle, of course, it generates that SQL ID for it. It has its own SQL ID. It has its own hash value, associated hash value, and you can see that information in the system tables. Now I'm using this query. I don't know if you have noticed here, I used a comment here. This is not really a comment. This is a hint. But one best thing with hint is if you don't give something meaningful, it just ignores it, right? I'm just using that loophole as a comment here. Now what I'm doing is I'm searching the GV $SQL. Ideally, you can just do $, because I have only one instance. I'm just searching for this string. So what it does is it gives me the respective SQL ID associated with this update statement. This is a SQL ID. In some other lecture, I'll explain about SQL ID. For now, SQL ID is a hash of this SQL, right? Whenever you run the SQL in the same syntax, you'll get the same SQL ID, at least in this database. Right, now let me generate explain plan. It's no more explain plan. You can call it as execution plan that this update statement used, right? This update statement got executed through this PL SQL script or through this script that we have run. And this update statement actually used table access full. Table access full, right? Okay. All right. So that is the major object I want to show you. But if I quickly recap, if you are a developer, I'm a developer in this black and white screen. I am expecting it to use an index scan. But what it did in fact used, it used a table scan, full table scan, right? When the updated records are very small, like 10 or 20 or 100, you won't really notice the difference, right? But when you are updating all of a sudden, like 100,000 or 10,000 or more than kind of records, you see a huge impact. This update itself running for these updates of those 10,000, 100,000 running for like hours and hours and hours. Now, the common thing you get from developer as a DBA is, what have you done? This worked perfectly till yesterday, suddenly it's taking long time, right? There is nothing happened from development side or DBA side, it's the data and it's a bad design, right? Now let me take this forward by this time giving employee ID as a number, okay? Now let me run this. Now let me pick up the SQL ID. Now let me enter the SQL ID. Now you see, this picked up the index. Why did it pick up index? Because if I go back here, I used number. There is no need to absolutely do a conversion here, okay? But whereas in my previous case, it has to go through a conversion. That you can see it under predicate information. It has to use to_binary_ float to match what is coming from application side and what is on the database side. It has to do that data type matching. In short, right? In short, what I'm trying to say through this video is data types, even though they look very small, are very crucial. These are the things that needs to be identified during the design phase, but we know how software projects go in live, right? So whenever somebody complains that it worked perfectly till last week, suddenly updates are overrunning, it means there is a type mismatch. I mean, it's not 100% always. You can think also in this angle. This is one of the angles you should look. With that, I would conclude this video. Thank you for watching, and please go and watch the next video.